study of gas laws. Okay, so I'm just briefing today that whatever we read till now. So in previous class, okay, you already knew about the some gas properties. If you see in your screen, you already knew about the gases. Okay, you know that these are very vast place of gases. One is very less intermolecular space. Okay, first thing you know that among these their molecules, okay, very less intermolecular space is found. Second, these are non-rigid, okay, and no fixed boundary is found in them, okay, and they are highly compressible. These are the things you already knew about them. You understand about a theory, okay, which we read. You understand about the theory which we read in the last week, that kinetic molecular theory. Okay, in this theory, what it theory said, these are three main points of this theory. First is gases are randomly moving and colliding with molecules and their container. Okay, suppose this is a container and gases are filled in that. Okay, so their molecules are continuously moving and colliding, okay, with the molecules and container. Okay, they collide with each other also. Then next thing in this, you read about each gas molecule have negligible volume compared total volume of the container. Okay, suppose this is a container in which gases are filled like this, gases molecule are filled like this, or this is one molecule. So the volume of that molecule is negligible. Okay, it means we cannot be uh, if you calculate this, okay, and if we compare it with a container, in a container the volume of that gas molecule is negligible. Okay, the third property of this is that force of attraction between two gaseous molecules is negligible compared to total attraction of container. Okay, suppose if you see, this is a molecule which I already tell you about it. So force of attraction between them, okay, is negligible between two molecules. Okay, two gaseous molecules, the total, if you say that attraction of container, if we compare with it, it is negligible. Okay, so this is the main postulates. Other things also are given, but these three are main postulates of this kinetic molecular theory of gases. Okay, so you can understand it. You already know that this is the main thing. Okay, if you want to study of gas laws, okay, study of gas laws, these things, okay, these things you have to understand, that temperature, pressure, volume, and mass. Okay, all the laws which you will be reading in your class, okay, it related to, okay, temperature, pressure, volume, and mass. Okay, these four things are always there. Okay, their alternation will be occur whenever you are going through these laws. Okay, so I hope till here you will understand that whatever things we have to understand. Okay, now we read about the uh, Boyle's law in last class also. Okay, we read about it already, that one condition you have to remember for the Boyle law is that temperature. Okay, in Hindi you can try to understand like boils means, okay, boil हो रहा है कहते हैं ना, so you can understand. Actually it is a name, but you can just for understanding that in this law, temperature will be constant. Okay, so if temperature is constant, the pressure of a gas is inversely proportional to its volume. So you already know that the sign of inversely is in 1 by. Okay, this is the sign of proportion. You already know that this is the sign of proportion. When he said that this is inversely proportional, it is written as 1 upon proportional. Okay, so according to this law, we can write that, we can also write like that. Okay, P inversely proportional to V. Then if we want to, okay, remove this proportional, and in the terms of equal, we can write it P is equal to constant. Okay, you know that this is the Boyle constant, and it is not it is written as capital K. So constant 1 upon V. Okay, this proportional mark will be removed from here. Okay, then what we can write, P is PV is equal to, when we multiply it with V, it will become PV is equal to K. Okay, so we derive this PV is equal to A after understanding the law of Boyle. So this K is known as Boyle's constant. Okay, I hope you understand it very clearly. We derive this law. Okay, first thing you have to understand, in the Boyle's law, temperature is constant. Okay, so if the pressure is inversely proportional to volume, okay, we can write it as it. Okay, it is derived Pv is equal to K, where K is Boyle's constant. Then for example, okay, if you take one example that a gas reaction is start, you can see in this portion. Okay, a gas reaction is start. Okay, in P1 and V1. P1 means when pressure, initial pressure and initial volume. Okay, of that gas. After completing this reaction, we will get the final pressure and final volume, which is P2 and V2. So if we compare with both, okay, there are two equations. Okay, you can see here that these are the two equations. P1 V1 is equal to constant. Okay, it is one equation, and P2 V2 is equal to constant. It is the second equation. Okay, then what we can do now, that from equation first and second, so these two are constant, so P1 V1 is equal to P2 V2. We can write or not that? We can write it as, okay, P1 V1 is equal to P2 V2, because both are the constant. Okay, so we can derive according to these two equations. P1 V1 is equal to P2 V2. Okay, you have to understand it very carefully, because you have to solve many questions. Okay, and many questions should be asked also in the examination according to this Boyle's law. Then these are the things which you have to remember when we read about the Boyle's law. Temperature is constant, first thing. Okay, then firstly we can derive it as P inversely proportional to 1 upon V. Okay, then P is equal to K upon V. Then we can also write that PV is equal to K. Okay, where K is constant. Then P1 V1 is equal to P2 V2. Okay, these are the things according to which, or on the basis of which, we have to do numericals also. So you have to understand it very carefully, where P is, okay, P is related to pressure, V is, okay, volume per meter and volume meter. Okay, and K is constant, and P1 V1 is initial pressure and initial volume. Then P2 V2 is final pressure and final volume, and T is a constant. Now one table you can see on your screen, that here, okay, there are some experiment. These are just examples. Okay, you can make your own examples also. So in first reaction, okay, this is a reaction, atmospheric pressure is 2, then its volume is 250 centimeter cube. Okay, then again this reaction, okay, 3 atmospheric pressure is there, and its volume is 125 centimeter cube. Then in final condition, atmospheric pressure of the gas is 4 atm, okay, atmosphere, and 65 centimeter cube its volume. So this is obeying Boyle's law or not? This pressure is first, okay, it's okay. So pressure is 2 atmosphere, and then volume is 250 centimeter cube in first stage. Okay. What is the Boyle's law said? That pressure of a gas is inversely proportional. You understand that when pressure is increasing, volume must be decreasing. Okay. So if you see that 2 atmosphere, okay, 250 centimeter cube, then it is decreasing 125 centimeter cube and pressure increasing, then volume again is decreasing, pressure increasing. So it is obeying the Boyle's law. Okay, so this experiment is following gas law of Boyle. Okay, now it is a question for you that you have to solve. That a question is a gas with certain volume having pressure 60 bars. The gas finally attains pressure of 90 bars when volume decreases to 500 centimeter cube. Find the initial volume. Okay, so this is the question in which you have to given pressure is given. Okay, and final pressure and volume given, but you have to find out the initial volume. So where PV is constant. Okay, so now you can see this is the hint for you that this according to this equation you have to solve P1 V1 is equal to P2 V2. Okay, P1 is given, P2 is given, V2 is given, you have to calculate V1, then find out this. Okay, what is the answer? Yes. Okay, very good, very good. Solve this for if other students don't know the answer, no? So you definitely got the right answer. You just these are the just mathematical equations. Okay, you can easily do that. If we have given the initial pressure 60 bar, okay, we just put this value 60 here. Then we have to calculate Vn, V1. We just write it as. Then we have given V2, which is 90 bars. Okay. Then we have to given 500 centimeter cube is the final volume of that gas. Then if we calculate it, then our answer will become 750 centimeter cube. Okay, so you all do a good job. But when I see that sometimes maybe in your class is not given that different values, sometimes it can be given in different values. Okay, here is this bar and in some atmospheric pressure, so you have to convert them. Okay, that's why the values which are given, okay, in your, if you see that in your equations or in your chapter in starting, whenever we read about there are different if you say that their volumes, okay, different type of volumes are given, so you have to understand and try to memorize them also. Okay, what the means of these bars, okay, where the value of the in atmosphere, okay, and I think in bars and atmosphere there is same digit for the volume, so you have to understand it. Okay, so today I'm just briefing you about the next law, which is known as Charles law. Okay, actually it is the relation between temperature and volume at constant pressure. Okay, and it is also known as Charles law. So in this, what you understand that pressure is constant. Okay, pressure is constant. In first one, Boyle's law, temperature is constant. So you have to understand it. So J. Charles, a French chemist, studied the behavior of gases at constant pressure and formulated a relationship between volume and temperature of a gas, okay, in 1787. So the experimental studies of the behavior gases reveals the following facts. So first fact is that when the temperature of a fixed mass of a gas at constant pressure is increased, the volume of the gas increase correspondingly. Okay. Then when the temperature of a fixed mass of a gas at constant pressure is decreased, the volume of gas decrease correspondingly. So whenever one thing you have to kept in mind that in all laws mass will be constant, okay, in a given mass means or in a fixed mass means the mass will be constant always, okay. So there is only change in the temperature, pressure and volume. So as you see here, by seeing graph, it is very much clear to you all that volume and temperature are proportional to each other. Okay, so these observations can be represented graphically as you see. So what by which means we can now stated the law of Charles that at constant pressure the volume of a given mass of a gas is directly proportional to its absolute temperature, that is temperature on Kelvin scale. Okay, absolute temperature means temperature which is in Kelvin scale. So V proportional to T is coming out from this equation. Okay, so you can see in first Boyle's law, okay, that these are inversely proportional when we write it as like this. Okay, inversely proportional, in inversely proportional the graph will become to down, and when directly proportional it is increasing or it is make like this. Okay, so now we have to understand two types of graph which is based on Boyle's law and Charles law. Okay, further things we will be discuss about it in very detail in the next class.